continue with example number 2. Okay, please read the question. Okay, from the question itself, we have few keywords. Okay, first keywords is continuous time signal. Then we have third keywords, which is resulting sequence, which is Xn. Means from this question we need to convert the continuous time to discrete time signal. Okay, and then we have the Xn signal is passed through a digital signal processor with unity magnitude response. Okay, this is the important keyword. If we have unity magnitude response, this one means your H exponent j omega is equal to 1. Okay? So basically, this is the keywords, the important keywords, unity magnitude response. And then keywords number 5 is an ideal low pass analog filter with cut-off frequency of 1 kHz. So basically, we have ideal low pass filter with FC equal to 1 kHz. Okay, when you see this one, low pass filter, definitely you must remember the low pass filter the low pass filter graph. We have from low to high, means from low pass filter, all all frequency which is less than FC will be taken as a signal. Means after any value which is greater than 1000 Hz will be cut off. Alright, this is for low pass filter. So next, after that is used to reconstruct the continuous time signal Yt to Yn. So basically we have another conversion, means we need to convert from Yt to Yn. So basically, if you look at number 3, keywords number 3, so what you have to do here, you need to convert from Xt to Xn. So basically what you have to do is you have to remember the ecosystem of continuous time signal to discrete time signals, same to keywords number 6. Alright, so first when you get the question, okay, so we have question, okay, what are the frequency component present in the reconstructed signal Yt? So what you have to do is, the question is you need to find the frequency component, frequency component in reconstructed signal Yt. Alright, so when you get the question, first thing first, okay, you have all these 6 information. So first what you have to do is you need to sketch the block diagrams based on the given information. So basically from our lecture, okay, you know that we have our input frequency, our input signal, which is Xt, and then of course we must have our impulse stream. Okay, so from impulse stream next what you have to do is, okay, the convolution between Xt and Pt will produce another signal, which is, for example, I give the name is Xat. Okay, and then from Xat we have a converter. Okay, why? Because of we need to convert from continuous time signal to discrete time signal. So we have analog to digital converter. So it will give you Sn. And then for keywords number 4, we have unity magnitude response H exponent j omega. Means after Sn, we have another block which is meant for H exponent j omega, which is equal to 1. Okay, so basically, as you know, okay, from X and H, you can get Yn, right? After that, we have ideal low pass filter log with FC equal to 1 kilohertz, and then we have to produce again still Yn, and then Yn after low pass filter. Okay, and then we have digital to analog converter so that you can get Y. Okay, alright, so we have xt equal to cos 1000 pi t plus cos 24 pi t. Okay, usually in final exam and midterm, okay, we always ask the student to find the the CTFT of xt. So basically, you refer to the formula sheet. You know that CTFT of xt is xj omega. Okay, and from the formula sheet also, you know that cos 1000 pi t, the CTFT of cos 1000 pi t is pi delta omega minus 1000 pi plus delta omega plus 1000 pi, and plus cos 2400 pi t is plus pi delta omega minus 2000 pi plus delta omega plus 2400 pi. And then if you were asked to sketch the spectrum, of ST, then what you have to do is you have to sketch a graph for the frequency domain graph. Okay, so don't forget to label your graph. If you forget to label your graph, then I forget to put the marks. Okay, so basically, if you look at the equation, pi delta omega minus 1000 pi plus delta omega plus 1000 pi. Okay, this one means delta minus 1000 pi means your spectrum, your signal is delta signal, and then 1000 pi plus 1000 pi minus 2400 pi plus 2400 pi means this is your delay part. Okay, means delta omega at one delay with 1000 pi. Okay, so you have 1000 pi. Okay, next delta omega at negative 1000 pi. Okay, so what is the magnitude? The magnitude is the amplitude of the signal is pi. Okay, same goes to this signal. Okay, so basically you have to delay your delta omega with 2400 pi. Okay, and then you have to advance the signal with negative 2400 pi. What is the amplitude? The amplitude is minus pi. Alright, so this is the example if you were asked to sketch the spectrum of xt. Okay, next, let's proceed. Okay, so next we have xt convolved with pt, and then you get xat. So what you have to do is you have to convolve your xt with your pt. So basically, when you convolve your input signal with the impulse train, okay, you will have okay. So what you have to do is xt convolve with pt. Then you will have xat. So xt pt is your impulse train. The value is always okay. So we have xt convolved with pt equal to xat, and this is equal to 1 over t. You have to include your 1 over t. So you will have cos multiply with 1000 pi t plus cos 2400 pi t. Okay, why we have 1 over t? 1 over t is coming from our last slide, our last lecture. We have, remember, we have the magnitude, which is pi times with 1 over 2 pi. Okay, so basically from after we convolve, we will have pi times 1 over 2 pi times 2 pi over t. Remember that? Okay, so that is where 1 over t is coming from. Okay, next, the CTFT of xat is same thing as a j omega. Now instead of you just have pi, now it already become pi over t. Delta omega minus 1000 pi plus delta omega plus 1000 pi plus pi over t delta omega minus 2400 pi plus delta omega plus 2400 pi. Okay, and then if you are asked to sketch the spectrum of xat, okay, means you need to refer to this one. Okay, so instead of you have the amplitude is pi, now it's already become pi over t. Alright, okay, so next, SAT going to the converter, okay, analog to digital converter for you to get XM. Alright, so to answer that, you have to remember the ecosystem. Alright, so from the ecosystem, you need to convert from continuous time to discrete time, and then from discrete time to continuous time. Alright, so for you to convert from continuous time to discrete time, you have to replace your t with nt. So basically what you have to do is, for you to get Sn, so you have to replace your t with nt. Okay, so for you to convert from Sn, okay, so for you to convert from Sn to Xt, what you have to do is you replace your n with t over capital T. So go back to your question. We have SAT equal to 1 over T cos pi 1000 pi T plus cos 2000 pi T. So we have SAT equal to 1 over T cos 1000 pi T plus cos. So what you have to do is you need to replace your T with NT. So replace T with NT. So what you're going to get is Xn. You replace your small t with NT. So what is the value for T? T equal to 1 over Fs. So go back to your question. Your Fs equal to 2000 kilohertz. So 1 over 2k. So your Sn is equal. Alright. So if you are asked to sketch the spectrum of Xn, this one is very easy. If you are asked to sketch the spectrum of Xn, so what you have to do is, the keyword is spectrum. Sketch the spectrum of Sn. So definitely when you see these keywords, automatically you know that what you have to do is you need to do Fourier transform. So in this case, this is DTFT. So DTFT of Sn is S E J omega. Alright. So from us now we have 1 over T pi delta. Okay, instead of capital omega, now we use small omega minus 0.5 pi plus delta omega plus 0.5 pi. Okay, plus. Okay, sketch the spectrum means, okay, you label your axis with omega, small omega. Your x-axis is x exponent j omega. Okay, and then this one we have delta omega, and then this one shifted to the left with 0.5 pi. Okay, and then shift to the right 1 over 2 pi. Shift to the left with negative 1.2 pi. Right. So what is the amplitude? The amplitude is 1 over t pi over t. Okay, so this is if you are asked to sketch the spectrum of Xn. Okay, refer back to our question. Okay, we have Xn and then it goes to H exponent j omega. So what you have to do is, okay, so you have X exponent j omega, you have H, and then you have Y. Y is your Yn is in discrete time signal. So what you have to do is, okay, Y and DTFT of Yn is Y exponent j omega. So how to find Y exponent j omega? It is X exponent j omega times h exponent j omega. From the question, we know that your h exponent j omega is equal to 1. So basically you know that your y exponent j omega is equal to y exponent j, your y exponent j omega equal to x exponent j omega. Alright, so now you have your y exponent j omega here. Now we have ideal low pass filter. So basically we have ideal low pass filter means you have to do your your yn will go to ideal low pass filter with FC equal to 1 kilohertz to produce YL low pass N. So what you need to do next is you need to find what is the value. Okay. Alright, so to answer this question, you must remember the sampling process equation, which is okay, this is sampling process equation. So basically YT is coming from your sample signal amplitude. Okay, this is 1/T is sample signal amplitude. Omega S is your sampling frequency. So from the question, we know that your Fs equal to 2 kilohertz. So basically, for you to get omega S is equal to 2 pi Fs. So you have this value. Sorry, this value is mainly omega S, capital omega S equal to 2 pi Fs, which is 2 pi 2000. So you get 4000 pi. But this value is basically in continuous time. So what you have to do next is you need to convert this 4000 pi value to discrete time. So how to convert to discrete time? You need to multiply this value with 4000 pi with capital T. So what you will have is 4000 pi u times with 1/Fs, which is equal to 2 pi. Alright, so what you have to do next is okay, you need to find what is the value what is the frequency after what is the spectrum at Y low pass filter, means Yn pass through an ideal low pass filter. So what you have to do next is you know that Yp exponent j omega is equal to, okay, refer back to your equation just now. Y exponent j omega is this one. So 1/T, you have 1/T the amplitude, so you will have pi/T y pi because it's coming from cos, so we have delta. We have yp exponent j omega equal pi over t delta omega minus 0.5 pi minus k omega s. Your omega s is 2 pi. Okay, so we have k 2 pi. Okay, so what we are going to do next is we are going to create a table. Okay, so basically we have k. Okay, k value we assume from from minus 1 to 1. Okay, so we have minus 1. Okay, why? Okay, basically for this one, for the k value, you can assume from minus 2 to 2, minus 3 to 3, up to you. But this one, why we have minus 1 to 1? Because of we need to find the low pass and the high pass filter. Alright, we want to see the low pass frequency and high pass frequency. Okay, next we have omega 1, which is referred to this one. And then we have omega 2, omega 3, omega 4. So what we are going to do next is you need to use a calculator to calculate the value. Okay. So from your calculator, okay, what you have to do is you substitute the k value when k equal to minus 1. So this one will become minus 0.5 pi plus 2 pi. So the value you get is 1.5 pi. This one, you substitute the value k equal to minus 1. So you will have 2.5 pi. Same goes to this one. You substitute k equal to minus 1. Then it is 0.8 pi. Then we have 3.2 pi. Okay, same goes to others when k equal to 0 and 1. So you will have this value. So basically, if you are asked to sketch the spectrum of YL low pass and okay, these two for omega 1 and omega 2, the amplitude of these two is pi over t. Same goes to these two frequency. It is pi over t. So what you have to do is, okay, just sketch the spectrum. Okay, so you have ypj omega, and then you have the your frequency. Okay, so first this one 1.5 pi, and then we have 2.5 pi. Next we have 0.8 pi. Here we have 3.2. Okay. Okay, next this one, okay, we have 0.5 pi. Next we have negative 0.5 pi. Then we have 0.8, 1.2 here. Then another one is here. Okay, I don't have more colors, so okay, we have 1 point. Then we have 3.2, 0.8. Okay. Alright, so for this one, okay, straight line represent upper sideband. Okay, sorry, for this one also we can put the dotted line, okay, is actually the lower sideband. Okay, so this one, the dotted lines is the lower sideband. Same goes to this one. What is the amplitude for this signal? It is pi over t. So if you have different amplitude for this and this, okay, I'm sure you know how to do that, right? Okay, so go back to our question. Okay, this one, if in case you are asked to sketch the spectrum of low pass band. Okay, so go back to our question. Okay, what you have to do next is you need to convert YLFN to YN. YT. So basically we have a converter, digital to analog converter. So again, what you have to do it is you need to remember the ecosystem. Means you have to replace your T with NT. And then here also you have to replace from that discrete time to continuous time, you have to replace your N with small t over capital T. So basically, this ecosystem, make sure you remember. Okay, so what you have to do next is okay, so you have this equation yp exponent j omega. Okay, alright, so basically you have this equation. What you have to do is you have to replace, you have to make sure, okay, yp exponent j omega is equation inside this ideal low pass filter. Okay, so what you have to do is, okay, you need to cut off, okay, the signal with FC equal to 1 kilohertz. Means you have to cut, okay, low pass filter is like this. Means you have to cut all frequencies which is greater than 1 kilohertz. So basically, you know that Okay, this value 1 kilohertz is basically in continuous time. So what you have to do is you need to convert this value to discrete time. So if you want to convert from omega c to small omega c, what you have to do is, okay, you have to, okay, sorry, yeah, this one 2 pi fc. Okay, so you will have 4000 pi. So basically for you to convert from this omega c to small omega c, you have to remember back the system. Okay, you have to replace your t with nt. So you have to multiply. Okay, this one 4000 pi, you have to multiply with t. Oh, sorry, it is not 4000, it is 2000. Okay, so 2000 pi times t, you will get pi. So what you have to do is, okay, you refer to your spectrum. Any value which is greater than pi will be cut off. So we are going to cut off all the value which is greater than 2 pi. Which is greater than pi. So basically we have here pi. So we are going to cut off all this value. Okay, so basically this value you can just ignore. Okay, so what's left is 0.5 pi and 0.8 pi. You have to do is, after cut off, okay, so you refer to this, okay, cut off all the value which is greater than 2 which is greater than pi. So you have 0.5 pi and 0.8 pi. So basically what's left is, so your YLFP. So you want to convert from low pass to continuous time. From discrete time to continuous time. So you will have, okay, you need to replace your okay, I'm sorry, this is y exponent j omega. So what you have to do is you need to transform this to continuous to discrete time. From discrete time to you have to make sure you transform it from frequency domain to from frequency domain to time domain. So this one will become 1 over t cos 0.5 pi n plus 1 over t cos 0.8 pi n. And this one for you to convert from discrete time to continuous time, you just have to replace your n with this and small t with t in over T is equal to Fs. So what you have to do is, okay, you substitute. Okay, 0.5 pi times 1 over T. So 1 over T is Fs equal to 2000. So 0.5 times 2000 is 1000 pi T plus 1 over T cos 0.8 times 2k is 1600 pi. So if you are asked to find, okay, and then if you look at this equation, okay, we need to convert from discrete time to continuous time. Now what happened, this 1 over T will be multiplied with T. This one also you need to multiply with T, because now we need to cancel this T off. Okay, we don't want this T off because this 1 over T represent sample signal. Okay, this sample signal, we need to have sample signal for us to convert, for us to do the processing. Okay, so that's why we need sample signal. So because of that, we need to cancel this T off. How to cancel this T off? We need to multiply it with T. Okay, so basically your new YT is cos 1000 pi T plus cos 1600 pi T. And if you are asked, if the question asks you to determine the frequency component of YT, definitely you know that your omega T is, your frequency component of YT, you know that your omega is equal to 1000 pi and 1600 pi. So your F, you just divide this one 1000 pi with 2 pi. So you have 500 Hertz and 800 Hertz. Okay, so go back to the question. The question wants you to find the frequency component in reconstructed signal YT. So basically from this one, you know that your F equal to 500 and 800 Hertz. Means your answer is correct. How to know that your answer is correct or not? You refer to your cutoff frequency. At low pass filter, low pass filter, we just accept the frequency which is less than 1000 kilohertz. Means more than 1000 kilohertz will be cut off. So means from your answer, you know that your answer is correct because these two value is less than 1 kilohertz.